Okay, now we are here, yeah, to learn about alcohol reactions. Okay, there are 7 alcohol reactions, and you can see one by one. It is a combustion, oxidation, reaction with sodium metal, substitution. There are 4 reagents that can be used in substitution reactions. Hydrogen halide, SOCl2, thionyl chloride, yeah, phosphorus trichloride, phosphorus pentachloride. Acidification, dehydration, and iodoform test. Okay, in this section we will cover reactions number 1 and 2, combustion and oxidation. The rest will be at the next video. You know that combustion reaction needs oxygen, so alcohol will react with oxygen, and in conditions in excess oxygen, the complete combustions will be occur, and the product is CO2 and H2O. Yeah, you just need to balance it, and yeah, usually you need to use the mole concept, yeah, in this combustion reaction. Okay, this is an exothermic reaction and will produce energy, but ethanol, ethanol and any other alcohols, okay, is at the conditions that we call as partially oxidized. Okay, partially oxidized. You know that ethanol already has oxygen, yeah, in its structure. So it is said that ethanol is already partially oxidized. So if you compare with ethane, for example, the combustion of ethanol will produce less amount of energy, yeah, than burning an alkane of comparable base. Is since once again this already partially oxidized, so it's just a next step for fully oxidized. Yeah, so if you see alkene, yeah, it does not have oxygen atoms at all. So this is this compound will gives more energy. Okay. Okay, since alcohol can release energy in its combustion reaction, so there are some future experiments to check whether we can use ethanol as fuel or not. Yeah, for our future, since you know that our fuel is limited. Yeah, because of very difficult to form the crude oil, right? So scientists try to find alternative such as ethanol as fuel. Okay, next. Write a balanced equation for the complete combustion of propane 1O and butane 1O. Okay, please pause this video and check your answer with me after that. Okay, let's discuss the answer. Propane 1O, that means you have this structure, right? But in this question, you need to write a balanced equation. So you're supposed not to use the structural formula to make a balanced equation. So instead of the structure, you should change it to molecular formula. So the alcohol with the propane 1O will have the molecular formula C3H, S3, S2, S2. So C3H8O, right? Yeah. And then combust with oxygen to form CO2 and H2O, because this is stated complete combustion. Okay, next, you just need to balance this equation. C3, 3C, H8, so 4. Oxygen, 6. This is 6, this is 4. Be careful, very, very be careful. We have 10 oxygen here. Yeah, usually students forget about there is one more oxygen in this molecule. They just think the oxygen is from the O2. So they just give 5 as the coefficient of O2. Oh, 10. Oh, I just put 5 here. They forget about this. But this is wrong, right? Okay. So what you should do? Okay, 10O minus 1 is 9. So you should use 9 over 2 O2 as the coefficient of O2. Okay, so 10. Okay, to make this the whole number, you multiply this by 2, right? So 2, and then 9, and then 6, and then 8. Okay, this is recall about stoichiometry, balancing. Okay, for butane 1O, still same, C4H10O. Balance this, 4, 5, 8 with 5, 13, 13 minus 1, 12, so this is supposed to be 6. Okay, that's about balancing equation for the combustions of alcohol. Now let's do this. Okay, let's check the answer. We need the equation. Okay, this is propane 1O, right? We just write the equation at the previous equation. Okay, which volume of oxygen measured at RTP is needed for complete combustion of 0.1 moles of propane 1O? Okay. Okay, this is 0.1 mole. So the oxygen's moles is 9 over 2 times 0.1, right? 0.45 moles. At RTP, the volume is moles times 20, 24. Use your calculator. It gives you A is the answer. Okay, so don't forget, if you see these types of questions, you should first change propane 1O to its molecular formula. Okay, then make the equation to show its combustion reaction. Then you can use the stoichiometric relationship to